Hi, dear students. Hope you are doing well. Uh, we have moved to lesson 11 and we are going to cover pages 275 to 281. So, the topic of this lesson is petrochemical and polymers. So, first of all, it's better to focus on petrochemicals. Petroleum is one type of petrochemicals. Petrochemicals is a very bigger term for a wide variety of products, which can be petroleum, which can be all the fossil fuels or many other industrial chemicals. So, fossil fuel, as we learn in high school, fossil fuels were formed in the Earth's crust from material that was once living. So it comes from the living things, which uh, they they were living in the previous time, but their dead body stored under the Earth's crust. And then, so it is required a long period of time to be changed to the fossil fuel. Um, Coal is a type of fossil fuel, comes from fossil plants material. So plants actually it's another living things, but fossil of plants material can provide coal. But petroleum is another thing. Petroleum or crude oil, also natural gas, both have same source. So they are formed from the body of marine microorganism. Marine microorganism like phytoplankton or zooplanktons are very small microorganism, actually, yeah, microorganism which are living in water resources, sea or very huge lake or marine. So their dead body can produce petroleum. But on the other side, the sources from plants material can produce coal. So all these three groups actually called petroleum and natural gases. These three are under fossil fuels. All of them are non-renewable energy. That means once they finish, then they cannot be recycled. And to be generated under the Earth's surface, it is required a very geological period of time, a very long time. So, all right, about formation of uh, petroleum, there is a short story in that page you can read by yourself, but I just highlighted the important point of this column. Petroleum or crude oil is one of the Earth's major natural resources, one of the largest amounts of natural resource actually. But as I mentioned, to be produced, it takes a long time. But there are some important factors for formation of petroleum. One can be high pressure. So, as we know, under the Earth's crust is high pressure, is not our environment. The pressure is 1 atmosphere, 1.2 bar in our environment on the Earth's crust, but under the Earth's crust there is a very high pressure. So formation of petroleum is needed a high pressure and also high temperature and the presence of bacteria acting over millions of years. So there should be bacteria to actually digest the dead plant or dead body of microorganisms, those things. So bacteria here is acting like a catalyst. If you remember, we learned about catalyst. Catalysts help to increase the rate of reaction. Here, bacteria is acting to um, acting and running the reaction under high pressure and high temperature. So of course, presence of the original organic material, which is dead plant or dead body of organisms, microorganisms, are the first need. So they are actually broke down into hydrocarbons. Yeah, the unit of petroleum's structure, also actually petrochemicals structure, is hydrocarbons. We learn hydrocarbons in the previous chapter, chapter 10. So that hydrocarbon come together and make a bigger hydrocarbon body for plants, proteins, DNA, and many other things in living living things. So when we when human get petroleum or actually crude oil from the earth, under the earth, it is required to be separated, and so we can get many different products from the raw material, raw crude. The way which can be applied is fractional distillation. Fractional distillation help to hydrocarbon molecule to be separated in the raw material, which is petroleum or crude oil. Fractional distillation, also this method is called oil refinery. That means you are going to refine, you are refining the oil, the petroleum. And the most important criteria that help to fractional distillation to separate the hydrocarbon molecules is a difference in boiling points of hydrocarbons. Hydrocarbons are different in boiling point. They show different boiling point based on their number of carbon atoms. We have one carbon atom with hydrogen, which is called methane, and we have, let me show you this table. Yeah, and we have two carbon, three carbon, four carbon. We learned about different carbon chain hydrocarbons in the previous chapter. So, which is called methane, ethane, propane, butane, pentane, and so on. So each molecule shows you different weight, different density. Different density leads to different boiling points. So when we get heavier, heavier hydrocarbons mean a lot more carbon atom or hydrogen actually, so we can get heavier molecule, higher density molecule. So the boiling point is higher. Why? What is the reason behind if molecule is heavier and boiling point is heavier also? Because when you boil the solution, the material under the heater, so the molecule is very heavy to be boiled and move to the gas phase and then fly up. So if the molecule is small, like methane, which is only one carbon, so you need to give less heat. less heat to the molecule get easily to be boiled and then to become a vapor because it's lighter, the molecule is lighter. So here, let's back to this slide. So boiling point, different boiling point of the petroleum, or actually crude oil, is related to strongly related to the number of carbon atom or weight, their weight. So at the right side, you can see those hydrocarbon which are light, so they can be separated at the top of the fractional distillation, but those are heavy are at the bottom and they are required higher temperature. So the fractional from the top of the tower is called light fractions or light hydrocarbon, whatever. And fractions from the bottom of the tower is called heavy fraction or heavy, also called heavy hydrocarbons, those things. But if you look at this picture carefully, you can find that the most demand useful of fractions, which is useful and variable for daily life, is the light fraction. Those hydrocarbons, those petroleum products which are light for gas, cooking gas or heating, also for as a fuel, gasoline for cars or motorbike, and also naphthala, and also for transportation, different transportation like airplane and trucks. But at the bottom is not very highly demanded. So that's why another method introduced to use the heavier fraction, heavier hydrocarbon, to convert it or to get some another and more light petroleum, which is highly demanded. This method is called catalyst cracking. For lighter fractions such as gasoline or petrol, the demand is greater than supply, the heavier one. So this picture also presents this issue, and the way humans are using the method to get lighter fraction or lighter petroleum is called catalytic cracking. Okay, during the catalytic cracking, we need to break down the carbon chain of heavier molecule. In this way, some catalysts, particles of catalyst, we learned about catalysts in previous chapter, such as powder minerals, such as silica, alumina, or zeolites. They are porous material. They are minerals. Minerals give larger surface area. We learn about surface areas. Giving a larger surface area and also enough heat, and putting a catalyst help for this reaction, make it faster and higher quality to get another light petroleum, another light fraction from the heavier molecule. Here we have a decane. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, 10 carbon is decane. And also using the catalytic cracking, we can break down the chain and get a 1 octane, which is 8 carbon, and the another 2 carbon can be separated as ethane. Okay, this ethane is useful for many applications. There are two possibilities for all cracking reaction. Cracking reaction either give you an alkane with shorter chain alkane and alkene, like the previous slide I show you here. So this is one possibility. The reaction can go through this way, or another way is giving you two or more alkenes and hydrogen. If you have a long chain of alkenes, so using this cracking reaction, it may lead to the hydrogen gas and the other alkenes. So these are two possibilities for all cracking reaction. After a cracking reaction, for example, here we have ethane. See what application can be applied by using ethane. If we get ethane, we can use it for many usages, like producing ethanol or producing many different polymers. We will learn about polymers. Is Polymers are containing and repeating different units, small unit like ethane, which they come together and make a very long chain, which is called polymer. The name is obvious. They have poly means many units, they are attached or joined together. So these are the most important products which can be made by uh, ethane, the ethane which is produced by catalytic cracking. And at the right side, you can see the laboratory scale, the small scale which can be tested, the catalytic cracking in laboratory. For example, you have a paraffin. Paraffin, as we know, is very heavy fraction, heavy hydrocarbon. As usual, paraffin is required a very strong heat and also broken particle of aluminum oxide granules, which play a role as here, as I said, we need a catalyst for cracking catalytic cracking. We need a catalyst like aluminum, silica, or zeolite. So here it use aluminum oxide granules. This gives a larger surface area. Then molecule go through a surface area. Then the molecule can be broken down, and then after separating the paraffin to another shorter chain, they can go through the cold water bath and then deliver to tube crystalline dish. So please keep in your mind and take a note for this picture. Any experiments picture in your book is important for your third section of IGCSE exam. And another section, blending gasoline. Blending gasoline can gives you many benefits to produce a better fuel for cars and vehicles totally. And there are many strategies to reduce the sulfurs and sulfur or lead. Nowadays, fuel without lead or very less percentage of lead present in the fuel is available globally all around the world. So, but this section is very easy to have self-study. I leave this section for you to have a self-study and for your memorizing. And that's all for today. We will continue next time for the next section. Thank you so much. Take care.